All right, case number 3 on the back side of day 5 notes. Okay. Day 6 notes, excuse me. And it says, given that -2 is a zero of the function, and we have this polynomial, algebraically find the remaining zeros. So again, if you tried to factor this polynomial, you would not be able to factor it. So what we're going to do is we're going to do long division, but we can't long divide by a zero. We have to long divide by a factor. So if we turn -2 from a zero to a factor, it would be x plus 2. Okay? And so now we're going to go ahead and take that x plus 2, and we're going to long divide it into our polynomial of 6x cubed plus 11x squared minus 17x minus 30. Okay? And we're going to go ahead and need a 6x squared up at the top. So that 6x squared times x is 6x cubed. 6x squared times 2 is a positive 12x squared. I'm going to go ahead and subtract. 6x cubed minus 6x cubed cancels, and 11x squared minus 12x squared is negative x squared. Bring down our negative 17x, and up at the top we're going to need a negative x, so that the negative x times the x is negative x squared, and negative x times 2 is negative 2x. We'll go ahead and subtract, and a negative x squared minus negative x squared cancel. Negative 17x minus a negative 2x is a negative 15x. And we're going to bring down the minus 30. Up at the top, we're going to need a negative 15, so that the negative 15 times the x is negative 15x. And the negative 15 times the 2 is the negative 30. We're going to go ahead and subtract, and negative 15x minus a negative 15x cancel. And negative 30 minus a negative 30 also cancel, but there's nothing left to write down, or bring down, I should say. And so I'm going to put a 0 there so I can see that that's my remainder. And because it's my remainder, x plus 2 is a factor, which we knew because they told us -2 was a 0. And now I can take that x plus 2 and the 6x squared minus x minus 15 as its second factor. If I were to put those two expressions back together with distribution, okay, I should get that original polynomial, but I don't want to put them together. I'm trying to find the zeros or the solutions. And so I actually already know one is x equals -2. That's actually the one that they told me. And that's why they said find not all zeros, but remaining zeros. We already knew that one. Okay. So if I look at this trinomial here, it is a hard trinomial and you can't get out of it. So let's go ahead and try factoring it. So in my x box, I would have numbers that multiply to 6 times -15, which is -90. And my add in the middle is -1. And that seems possible with the numbers of 9 and 10. And to get a -1, I need the 10 to be negative. So if I multiply them, I get the -90. And if I add them, I get the -1. So this is factorable. If it wasn't, I could go and do the quadratic formula, or I could do the quadratic formula now. It doesn't make a difference. Okay. But I'm going to go ahead and factor since I already found the numbers. So I'm going to rewrite 6x squared plus 9x minus 10x minus 15 equal to 0. We'll group the first two, group the last two. Out of the first group, I can pull out a 3x, be left with 2x plus 3. Out of the second group, I can pull out a -5, and left over would be a 2x. I pulled out a negative, so that flips the sign to a positive 3, and they match. So 2x plus 3 is a factor. 3x minus 5 is a factor. And I end up with x equals -3 over 2, and x equals positive 5 over 3. And there are, well, I already knew that one, but these are the ones that are the remaining ones. Okay, but all three are zeros of our function here, and it makes sense that highest exponent is 3, and we ended up with 3 answers. Okay, all right, let's try last question. Number 4 says to evaluate j of -1 when j of x equals, explain what your answer tells you about x plus 1 as a factor. Okay, so j of negative 1 would equal 2 times negative 1 to the 4th minus negative 1 to the 3rd minus 35 times negative 1 to the 2nd plus 16 times negative 1 plus 48. That's a long polynomial. That's a lot to type in, but here you go. When you do type it all in and you hit enter, you do end up with 0. And so what that says is since j of negative 1 equals 0, negative 1 is a 0. So x plus 1 is a factor. Okay, so we answered the question and we explained what that tells us about our x plus 1 as a factor. Okay, and so now we're going to go ahead and answer the rest of the question. That says algebraically find the remaining zeros. So now that we have a factor of x plus 1, we're going to long divide it into the polynomial up above, which is 2x to the 4th minus x cubed minus 35x squared plus 16x plus 48. Ooh, okay. So up at the top, we're going to need a 2x to the 3rd. So that 2x cubed times x is 2x to the 4th. 2x cubed times 1 is 2x cubed. Use our minus sign. 2x to the 4th minus 2x to the 4th cancel. Negative x cubed plus 2x cubed is 1x cubed. Oops, excuse me. Negative x cubed minus 2 is actually negative 3x cubed. Bring down my minus 35x squared, and up at the top, we're going to need a negative 3x squared. Negative 3x squared times x is negative 3x cubed. Negative 3x squared times 1 is negative 3x squared. Put our minus sign and subtract. My first set of terms cancel. Negative 35x squared minus a negative 3x squared is negative 32x squared. Bring down my next term, which is positive 16x, and we're back up at the top, needing a negative 32x. So negative 32x times x is negative 32x squared. Negative 32x times 1 is negative 32x. We'll go ahead and subtract. And those are going to cancel. 16 minus a negative 32x is 48x. We'll bring down our last term of plus 48. And up at the top, we're going to need a plus 48. So that 48 times x is 48x. And 48 times 1 is 48. Put our minus sign and we will subtract, and those will cancel. And 48 minus 48 also canceled, but there's nothing left, so I'm going to write equal 0 because that's my remainder. Okay, meaning that x plus 1 is truly a factor, just like we figured out in the first part. And so we're going to take that x plus 1 and our polynomial of 2x cubed minus 3x squared minus 32x plus 48. And if I were to put those two back together, I would end up with the polynomial that's underneath the division sign. But I don't want to put them together. I want to continue to take them apart. And there is the negative 1 that I knew was a 0 from part A. Okay, but again, they wanted me to find all the remaining zeros. And so the 3 that I have left to find are going to come from this polynomial here. And I can't use quadratic formula on it. It's not quadratic, so I'm hoping factoring works. There is nothing in common that I can pull out. However, I can group, and hopefully factor by grouping works. I can pull out an x squared and left with 2x minus 3. Out of the second group, I can pull out, I believe, 16, except it's going to have to be a negative 16. That way I'll have a 2x minus 3 left over inside, which is good because that matches. And so 2x minus 3 is my factor. X squared minus 16 is another. This one is going to give me x equals positive 3 over 2, whereas this one is a D2PS. I'm going to keep factoring it. And that's going to give me x equals negative 4. and x equals positive 4. And so there are all my solutions. X equals negative 1, x equals 3 halves, x equals negative 4, and x equals positive 4, which is the 4 solutions because it was a fourth degree polynomial, and there they all are. All right. Whew. All right, guys, I'll see you on the next day of notes.